I'm coming. what's up, man? Link to the StreamYard is in the description for anyone who wants to join in. We'll talk about switching circuits. What we got here? Go back a little bit here. That's the complete circuit. And be 4 transistors, 2 pairs. You would trigger 1 pair per battery on the negative and the positive of the same inductor. And it just flies back to the opposite battery. And I erased half the circuit to make it a little bit more visible. Hey, Mikey.
Hey, how's it going?
How you doing?
Good, good. Yeah, just running my motor. Just running my motor right now.
Yeah.
Let me change my camera here.
Links in the description. StreamYard link.
So I got it running. I'm just trying to recondition the battery right here. So I've had this motor running for about pushing 2 hours now, and it's what's powering the system is this 3 9-volt batteries.
27 volts.
Yeah. So that's what's powering the whole system right now, and it's been running strong for the last 2 hours. So, the potential that I'm putting into the system is so tiny. This motor runs off voltage, not current. This thing will probably run till tomorrow, because I can't even register a current reading coming off those batteries. Just stop pulling a load off it. So this motor runs off potential, not current. So right now, this battery here I'm charging is at 12.44 volts and climbing. This battery's kind of pooched. It's not really holding a charge. Got about 12.64 in this one. This one's 12.44. So it's holding. So usually when you get to a certain level in the battery, it'll just kind of sit there. So I just let the generator do its thing and just condition the battery. So
you're throwing the flyback into that battery?
Yeah. So it goes into this capacitor here. And this capacitor is 60 volts at 12,000 microfarad. So it's sustaining 13.72 volts in there. And then it goes to the full wave bridge again. And then into battery. So it's sustaining 13.7 volts. That means there's a current push from the capacitor into the battery. So as long as this current or the voltage in this capacitor exceeds the voltage of the battery, you always have a constant current flow going into the battery.
Right, right. So wait, you got the capacitor capturing the flyback first, then.
Yeah.
Right. That way
So I'm
it exceeds the voltage.
well. The whole point, like, I'll kind of explain the circuit. So the initial power is coming out of here. So I'm actually using the Tesla one-wire system. So up the red wire here, I'm patching it and I'm putting it through this transformer, and then from the transformer goes to the end of the light or the negative. So basically, I'm just tapping off the one side of the circuit from the main motor itself. So from there, I dump it right into a full weight bridge, and then it goes to the capacitor, and then from the capacitor it goes to another full weight bridge, and then it goes to this battery. Now,
How
the
come you
reason
don't go
why
directly from the capacitor to the battery with just a
I can't,
diode or something,
I could, if I wanted to, uh, but
or
the
no
way I have
diode at
it,
all?
well, the way I got it set up right now, I could actually take this flyback and actually run it right back into the drive battery without shorting out the circuit. So I could do a complete loop with
Run
the
it back
circuit
as
set up.
flyback or run it back rectified?
You have to break the symmetry. So when you break the symmetry,
So you
you
rectify
dump
it
it.
then.
Yeah, I rectify it, break the symmetry, dump it into this big capacitor here. It changes that flyback energy into real power. It's very important. So now that I've completed
Why
it,
do you have to break the symmetry again? What was the
well, if I
reasoning?
do, well, basically you'll short the motor out. So if I'm using, say, these two batteries to run the
Oh,
system, and if I were to loop it back into itself without this circuit,
you'd
it would
short them.
basically it would short the motor out. So you have to break the symmetry of the current to regular power. As soon as that's done, as soon as you
And you
break
do
that
that through like
symmetry,
isolation of the.
well, the bridge rectifiers are actually doing the isolation.
Right, right.
So because of that, that the symmetry is broken, the battery doesn't realize the power that's coming back into it is the battery that it was feeding the system. It fools it.
Right.
So so the way I have it configured now, I can fully loop it without shorting out the motor. Where most people have a problem with that. So it goes back to Bearden. What Bearden was saying.
Loop
You
it
have to,
without shorting out the motor.
yeah,
Well, it doesn't. Well, the loop can happen during the flyback. And if you
yeah. But if you
and
don't break the
there's no way to short out the motor because the gate of the transistor is open.
it will short it out. You'll draw the battery down. You'll notice the battery will drop, and also the RPM of the motor will start slowing down. I've
Even
done it.
though the gate's open.
It doesn't matter. It's the symmetry. You have to change the waveform of that power, reaccumulate it. Even Tesla talks about this in the circuit. He says you can take any energy, and the second you dump it into a capacitor, you're changing the symmetry and you're changing the dynamics of the power. Now you can do
Right.
whatever you want with it. So,
Is this system drawn out on your Patreon?
oh yeah, yeah, yeah. It's in my
It's the
Patreon. I got the full
the
schematic in there.
Renegade.
Yeah, the Renegade device.
You have
Yep,
a schematic there. Okay.
I got a couple of them in there, and I also
I'm
got
new
the
to
one.
Patreon, so I don't really I haven't really navigated through there yet.
Yeah, I got that circuit and also the Tesla one-wire system, which is super easy and it works. So the second I hooked it up, I was able to loop the motor. I'm like, holy cow, this really works. So as long as you're not killing the dipole, meaning see this light. See, if I looped it the way that most people would, this light would actually go out, and that's when you know you've killed the dipole and you've shorted the motor out. The
Makes
way I
sense.
have it hooked up, the way I have it hooked up now, that light is staying on. All right, it's pulsing. Now I also have the neon bulb. You can see it right there. So that's fully lit right now. That means I got minimum 90 volts going through that neon. So I'm getting considerable amount of flyback.
Right. Yeah, and all the flyback, you're channeling it back to the other battery with the
So,
transducer in
yeah,
parallel.
yeah. So there's the neon light. You can see it's fully lit. And I got the two transducers under
Can
the
you
wheel
bring the
there.
circuit up real quick?
I don't have it where I can actually pull it up.
Can I go to your Patreon and find it? Or
Yeah, yeah.
go can I bring it up there?
All these circuits are online. They're not hidden. They're there. You just
Like,
have to go and look for it. So Tesla one wire system is what I'm using, and with that system, it will keep the dipole running, and it will also help you when you break the symmetry down, so you
oh
can
wait, I had to
basically,
log in, huh?
yeah, you're probably
Hmm.
gonna log in.
Oh yeah, I use my Google, right?
Yeah.
Ah, okay. I'm on your channel. What's the I searched for the Renegade, right?
Yeah, Renegade, and it'll probably be in pictures,
Do I have to scroll
photos.
down or can I search for it?
You could try both. I'm not sure because I don't really log into it like that. I logged in the
Let me try
administrator.
RE.
Or just scroll down in the pictures that I posted there, and you should be able to see something there.
I want to see the Renegade circuit.
Yeah, I got it there. Pulse
Hmm.
motor circuit.
So it's
So
simple.
it's a very simple system. It's like when you look at the circuitry or even the diagram, it's so ridiculously easy. Like,
So I guess the diagram is in a video. It's not like a picture or nothing.
no, I have pictures posted.
How do I see the pictures in Patreon?
There should be a list there where you can see photos. Might go by actual posts, so you might just have to keep scrolling down.
So I'm on your channel. I got home collections membership about collections home. In your home channel, I see a bunch of the videos on there. Oh, media type,
Yeah,
image.
images might be under that.
The Renegade April 6th. No. Ah,
Did you find it?
I think that's it.
Pull it up on the screen, then I can see it, and I'll tell you if that's it.
Hold on here. So, can't download the picture from
It'll allow you to download it.
Save Images.
Find that's the browser. I don't know. I haven't gone like in as like a member. I've only got the
Ah, there
administrative
it
side.
is. Hold on. Input here. Save. Okay. Oh,
Not allowing you
pictures.
to download it.
Renegade. Renegade. I think that's it. Let me see.
Pull it up on the screen so I can see it, and I'll tell you right away.
Is that it?
Let's see. Yeah. Can you zoom in on it?
Hang on.
Yeah, that's it. Yep, that's the circuit. So the box there, that's the switch. So it's showing you
Let me know
how
when the
that.
whole circuit shows up on the screen.
Yeah, it's completely there. Yep. So you can see. Oh, maybe put it in full screen. There you go. So it starts from the battery. So the battery, you could actually hook up a single throw switch on it for power on, power off. So there's the the square box there that you see there. That's the spark gap switch, the 12-volt relay. So it's two parts. One is the line in and line out for the power that goes to the coil.
Mm-hmm.
As you can see, the ground wire is actually a common ground to the coil. All right. Now the two prongs on the left and right of the box there. Yeah.
The ground
Uh,
wire?
yeah. So see the box there? Yeah, right there. No, you just have it. Okay. So that's the
Here?
spark gap switch. Yeah, right there where you are. So
Hmm.
the pin on the left and the right is hooked up to a battery,
That's your
and
relay.
you'll see the reed switch. Okay. So you can either have a reed switch there, or you can have a proximity sensor there. So you have the choice. So that circuit there controls basically the connection that goes to the coil. So you can follow the line of the coil, all right? And it goes to the positive side. Now, ground is common, all right? Now, from the where the relay switch is there, the positive wire coming out the top, okay?
Uh-huh.
You could actually put a flyback diode there if you wish. I didn't
To
put it in
protect the
there.
relay. Put it on this side, huh?
Not there. No, that's the trigger. You want to go where the
No, I mean
pluses
put
are.
the diode here
No, you don't need it because it's isolated from the rest of the circuit.
by this,
It's it's isolated. Yeah. So the pin
by
at the
that.
bottom, the pin at the bottom, and the pin at the top. Okay, in the middle there, the one at the bottom and the top. Those two are normally open. So when the reed switch actually fires, the top pin and the bottom pin that's standing up vertically there on the bottom, those are now connected. That's your open and close right there.
Right. It's
That
normally open.
normally open, right? So as soon as that closes and it becomes one line, now the power flows up from there to the coil, and that's where it's fired. So
Well, it's
when the
to the
reeds,
coil right here, closes the switch,
the switch is separate.
allowing, you're
No,
switching the negative here. You're switching the negative of the battery here.
no. Look at the circuit.
The
The
negative
two
of the
pins.
battery. You're switching
Hold
it.
on, hold on. The pin on the left and the right side, that's
Hmm.
just for making the switch open and close, nothing
Right.
else. It's isolated completely from the bottom pin and the top pin. Okay, the
Right.
two and the all right, so they're completely isolated. So it allows the battery to flow power from the bottom pin where it says plus there to the top pin at the top of the box, and that flows the power to your coil.
Right.
It's like two separate circuits in the same
I
relay
see.
switch, right? And it's just, normally open. So as soon as you energize it with the reed switch, the battery just provides the power in order for it to open and close. So it pulls such little power, it's almost totally insignificant to the system, and it's isolated from the system. So if anything were to go wrong, it won't short out your reed switch or kill your proximity sensor. That's the purpose of that. So now it goes to the coil. So the coil in the middle, the big
So
red
you're switching the
circle.
positive of the 48-volt battery here through here.
Yeah, right. It jumps there when it gets closed, and then it
Gets
pulses the
closed
coil.
by this battery here, and you switch the
Battery,
read.
right. The
You
rate,
trigger the read with your magnet to switch the positive to energize the relay,
That's
to
right.
close the switch. Right. Okay. That's how you're
Exactly.
isolating that switch. I got you. So you're
Yeah, you got
using
it.
one switch to create another switch.
That's right. Yeah.
Yeah. Yeah.
And
Makes sense.
so I use a
Simple
proximity
enough.
sensor. Yeah, it's very basic. It's very basic, incredibly basic, and it gives you the option. You could use a reed switch there,
Mm.
or you could use a 3D printer proximity sensor
You
like
mind
I'm
if
using.
I redraw this out when I get time?
Sure, you could do
And you
whatever
can
you
use
want
it on
with
your
it.
channel.
Sure, you can do whatever you want with it.
I'll
It's
just redraw what you got here on the computer, like as best
right.
I can digitally,
So, okay, so let's go to the main coil. So we got the drive coil in the middle there. Okay, that's what's pushing
This
the
one.
motor. So the one in the middle, yeah,
Oh,
yeah, that one.
this one.
That
This one.
no, the one above it. That's the transducer above it. So the transducer is in parallel with the
24
coil.
gauge.
Yeah, 24 gauge, minimum 1 pound, and the circle above it, it says piezo. So it's running in parallel with the coil.
Right.
And
And
then
then your
from
load.
there,
Nice.
right, right. So off the positive side, beside the piezo there, that's where you
So
would make your,
the flyback is funneling through the piezo
yep,
before the load.
yep.
So it's acting
That's
like a
kind of like a gate in a way.
I'd
It,
say that
it,
the
it's
piezo is acting like a storage device
resonating.
for the flyback
Right, but it also,
to be utilized right away.
yeah, when I've hooked up that piezo there right to my scope, it's showing about a 13 kilohertz signal. That's what it's showing me on the scope, about 13 kilohertz being generated in the piezo. It's capable of doing 42 kilohertz, but the scope is showing me about 13 kilohertz. So what it's doing is hyper resonating the coil and creating the
So
reactive,
what's going on is you're pulsing at a lower frequency, but the piezo is
stepping it up,
it's multiplying the frequency.
right, by a huge factor. That's
That's
why I had
cool.
such a that's why I had such a huge power gain. Like the second you take that piezo out of that circuit, the circuit dies. It's not anywhere near the amount of power I get the second I hook it up. So my Renegade's got two of those in parallel. So you could actually draw another one in there. So this is the most basic circuit I was able to draw out, so people would just get the idea of what I'm actually doing in the circuit. And it's a very basic but yet incredibly effective circuit. Now you can start, as soon as you understand this basic circuit, now you can start adding diodes or adding an extra, maybe a capacitor in there and modify off it. And so I took the line going out that's going to
And
load.
again, you isolated the actual inductor switching switch
Yep,
because you didn't want to have your read go bad.
that's right. And I was blowing reed switches left, right, and center. I got a big graveyard of them.
Yeah, I blew my first 5 pack. And
I
then
blew a
I
lot.
bought
I blew
another
a lot.
5 pack of beats, but the higher amperage ones, and I never even
Yeah.
bothered using them because they
Oh
were
God.
so much money. I didn't want to blow them.
Yeah.
So I
I
might use
have
them
the
now with this setup.
yeah, the ones I had were the really good vacuum tube ones from Russia. They only make
Mhm.
them in Russia, and I was blowing the snot out of those things.
I have Russian coil wound resistors and Russian potentiometers and Russian
Yeah, that's
transistors,
the yeah, that's
matched
the only place.
six matched ones.
Yeah, like the Russia
I
right
never used
now.
them.
I guess in Russia and the Baltics, that's the only
I
place that
bought this
gets
stuff like
really good.
almost 10 years ago.
Yeah, it's hard to get now because a lot of this stuff isn't made anymore. You can only get it in the Baltics, and if you have a surplus in your area, by chance they might carry it. And I have the advantage. I got a really good surplus guy that's about a 40-minute drive from my house, and it's just I walk in there, it's like bloody heaven in there because there's just stuff in there you can't get anymore. it's obsolete stuff, or it's just not manufactured anymore. So yeah, it's been a real big help, going to this place where I go to in Toronto. He's the only real quote unquote surplus guy that I know of that's still around, right? Anybody who's heavy duty into electronics, they pretty much know who this guy is, and he's the go-to guy for surplus stuff, anyways. Like the blue capacitor there that I had in my circuit, I got it at his place. The neon bulbs, I got it at his place. A lot of the connectors and all that kind of stuff, I all got at his place. The magnet wire, he's just the only guy that carries this stuff, you know.
In
But
Toronto?
just before Toronto, just on the outskirts of Toronto. So it's about a 30-minute, 40-minute drive from my house. It's not too bad. It's usually only because of the traffic factor going in there.
Oh,
Sucks.
there's Anthony. What's up, Anthony? Didn't see you till just now.
Hey, how's it going?
Hey,
How you doing?
how's it going?
Hey, fella, you lived in Silicon Valley. You'd have plenty of surplus.
Yeah,
Is the audio working?
Yep.
Yeah, I hear you.
like,
Okay. I got a different camera, so I wasn't sure. I haven't tried this one yet. Hey, is
we had
the
a good
pico
show.
element acting like a tank circuit? Because that's what it kind of looks like.
It is. It's a tank circuit. That's exactly what it is. It's it's basically an open loop tank circuit, if that makes any sense. The light is kind of that junction that actually keeps the circuit kind of open. So I'm not killing the dipole in my circuit. So yeah, I've been running it on these 9-volt batteries tonight for the last 2 hours plus, and my motor's still running strong. I'm just doing some battery conditioning right now. So he just had my circuit up on the screen there. Basic.
You know, something might be interesting is if you just power it from a small battery and stick it on one board, hook it up to like a 5-digit voltmeter, and get on an elevator. Because Bedini said the back EMF is related to your altitude. I'd like to do it and say go up 20 feet as high as you can get and see if it doesn't, you don't start getting more power out.
Yeah, I got the Niagara Escarpment right beside me. It's about 10-minute drive from my house, and it goes up about well over 500 meters. So
oh, really?
I'm definitely gonna, yeah. So it's quite a big little peak there. We call it Rattlesnake Point. It's right at the north end of the Niagara Escarpment. So
is that kind of like a mountain or something?
Yeah, it's where the landmass basically, I know it was like 6 million years ago, it dropped. So that peak stayed up high. And where I live at the bottom of that. So I'm right at the very end of the north end of the Niagara Escarpment.
Right. That might be even better because I was thinking if you do it in an elevator, all that metal might interfere with things.
Yeah,
I don't know why the back EMF it would increase, but
I think it would. I really think if I go to that peak there up in Rattlesnake Point, I'll probably have quite an interesting result in my high voltage output. Because right now, like my large Renegade, my high voltage spikes were hitting about 3/4 of a kilowatt. Now, if I were to take that same device and bring it up there, I'll be well over a kilovolt for sure.
What kind of diodes are you using?
Sorry?
What kind of diodes are you using? Like regular, like 1N4,
yeah,
like Schottky or?
Yeah, I'm using the N4007, 4003, or sorry, 4001. That's about it. I don't really have a heck of a lot of diodes in my system. I'm
trying to replace them all with Schottky. I'll bet you get better results.
Yeah, the Schottky diodes. Yeah, I'll have to get a hold of them. They're kind of hard to get now. I'll have to go to my surplus guy and see if I can get a few of those.
Or you can buy them new still. They're in pretty much all the switching supplies. All your TVs now, but Yeah, like you said with the surplus places, man, they are getting hard to find.
Yeah,
Just
and I got
like
one.
Radio Shack, it's like they actually used to have parts, but man,
Yeah,
it's really hard to find parts now.
yeah. This guy here is a treasure chest, and his facilities. You walk in there, it looked like a tornado hit the place. But anybody who knows anything about electronics, when you start walking through there and see the depth of what this guy has in the inventory, is just unbelievable.
And we used to have a place called Mendelssohn's Electronics. It was like damn near an acre. It was like just the third floor, like the entire floor was just like, there was like 3 or 4 rows of just resistors, 3 or 4 rows of just capacitors, and I mean the place was enormous.
Yeah,
But they finally went out of business, and I don't know what took them over, but it's like, man, it's now the only one I know is like a one that's, I don't know, maybe like 50 by 50 feet. That's close to here.
yep.
And I'm near
And
the
then
Dayton area, so you think there'd be a whole lot of them because we're technical area. Plenty
yeah,
of engineers around here because we're right next to Wright Pat, and
yeah. You know what the problem is
Ray
now?
Patterson is in Canada
No,
or
no,
no,
I'm not
Ohio?
in
You
right,
Canada.
saw
I'm
you're
right.
in
in
Ohio.
I'm right next to Dayton, Ohio.
You're in
Yeah,
Ohio, okay.
Yeah,
yeah.
actually Wright Pat's like maybe
That's
a
near
mile and a
Canada
half
still,
from me.
though.
What's that?
Isn't Ohio like bordering Canada?
It's pretty close, just below Chicago, and yeah, it's just below the Great Lakes, not far.
Yeah, at the bottom of Lake Erie, I think.
Yeah, yep.
But
I'm not too
we're at
far.
the bottom of the state, not the top of not the top of the state, like
Yeah,
the
like
southwest
it's
So
corner.
is this? Do you guys
like
see
from
this circuit up here?
Yeah,
yeah.
Is it confusing you guys, or is it making any sense?
it
There it
makes
is.
sense. It's a little hard to tell by the way it's drawn, but
So it
Well,
is
what it
kind of
is
confusing then.
it's a tank circuit. That's what I'm looking at.
Pay
It's a
attention to the
tank.
switches, the switches, the 2 switches on
yeah,
each
timing
battery.
diagram would help too.
No, the switches are moving.
Well,
The
that's what I
switches are
mean
moving.
to show
Yeah,
when they're changing.
yeah, yeah.
They're
You basically
changing.
got
Look
a
at them.
yeah, yeah, yeah. It's a tank circuit, but it's like a flyback tank circuit. You're
Okay,
you're you're switching from one battery to the other battery, depending on what switch is going off and driving through the system. So it's basically like a two a 2 lane highway, you know, to battery one, and then
right. And here's the
got
other
the
one.
switch.
It took me a minute on the other circuit diagram when you had that
Now
Foley's
here,
bridge
look,
on
look,
there.
look. Here's the same circuit.
Right.
I erased half of it, so it would
Yeah.
make more sense.
Yeah,
Yeah.
that's a lot easier to see.
Yeah.
Now does it make sense?
Yeah,
Yeah. Yeah.
Now that you see they're just 2 circuits, right? And now go
The
back to
switch
the
is
other one.
making the separate. Yeah, the switching is making the
The
separation
switching is
between the
separating.
path. Yeah, the separating it and changing the direction of where it's going.
Hold on.
yeah.
We go to the other one
Excuse me.
now.
Yeah, that makes it much easier to understand.
Yeah, now let me you see the other half now. Watch. Here's the other half. It's just showing you the flyback happening there because the switch is open, And now the other half of the circuit shows up right there, and it's charging the inductor. The switches are closed, and then the 2 switches open on the battery there, and it flies back into the other battery, right? Does back and forth between the 2 batteries and the 2 inductors. And then go back to this other video here where it shows the whole circuit as in the whole circuit here now. This is the whole circuit. And now this is the whole circuit operating. I'll let it play.
Have you actually built it? Have you built this, Mike?
I built it with 2 switches only.
And
what happened was the flyback was feeding the other inductor and back and forth. Each
okay,
inductor was flying back into each other when I only had 2 switches.
right.
And I was only
So
switching, I believe it was the positive of the 2 inductors. Now I'm switching the positive and the negative of the two inductors to make sure that the flyback does not go into the other inductor.
So what's your result as far as power gain?
Well, this circuit here shows it going into the other battery back and forth from one.
Right.
So the battery, the inductor on top of the battery is the one getting charged by that battery.
Right.
But the inductor on top of the battery is not flying back into the battery that's under it. It's flying back into the battery to the other side.
Right.
You should draw yourself a timing diagram so you can separate that. You know,
look at the switches. They're opening and closing, Anthony. They're all open. See, they're all open now. Only two close on the right. Now they're all open. Now only two close on the left. Now they're all open. Now only two close on the right. Now they're all open. Now only two close on the left. Now they're all open. That's it.
Yeah, it's a flip-flop circuit.
That's all. Reed switches.
4 transistors. You can trigger 2 pairs at the base.
Yeah.
Okay, you're using transistors. I thought you was using reed switches.
You can use anything you want. But
I didn't know it. I was talking to one of the guys at the surplus places. I thought the reed switches only came in like the little bitty things. He said you can actually get them to like 20 amps or more.
So it makes sense.
I've never seen one like that, but apparently they exist.
I blew too many up. I got a graveyard of them.
Yeah, no, you don't have to use transistors. You can use reeds or.
I had the vacuum tube ones made in Russia. They blew the crap out of those things.
All I've ever seen is the little bitty ones, and they're not happy about working. After a while, they wear away.
Oh yeah, exactly. I had the ones that were 2.5 inches long in the vacuum tube, the green vacuum tube. They could take a lot of power, but I still killed them. That's why I went to the isolated circuit to separate the actual triggering of the coil separate from the actual switch mechanism that triggers that switch. So I isolated that. And they haven't really blown the reed switch. Well, I use a 3D printer proximity sensor with a super fast switcher.
No, I haven't built that yet, Anthony.
Is that a FISO? Oh, I'm sorry. Is that a FISO like the ultrasonic transducer FISO? Or is that like a buzzer?
Yep, it's the piezo barium titanate transducer.
Okay.
I got 2 of them. I got 2 of them in my circuit. The one on the screen there just has the one. But that's the basic circuit of how my system works. I've added stuff onto it since then, but this is the basic circuit. So that box that's at the bottom there with the 4 pins in it, that's the automotive relay switch. So the triggering mechanism is.
Oh, that's not a full-wave bridge? I thought that was a full-wave bridge.
No.
Okay, that's why it didn't make sense.
No rectifier here. I don't see anything.
No, I didn't put a rectifier in it. You don't. The basic circuit, you don't need it. I wanted to keep this as the basic circuit. That's in my Patreon. So
okay, that makes more sense now. So yeah, I seen that and I was like, okay, well, I guess you could do that in the full-wave bridge, but I've never seen it used like that.
No, that's not a full-wave bridge.
Well, he's just
right. Yeah. I know. With the first time I seen it, it was like,
Yeah.
But that's a perfect way to isolate your.
Yeah,
you're using the little coil inside that relay to do your
energy. Yeah, energizes the. Yeah, energizes.
Actually, your trigger coil is that coil inside the.
Yeah, that's the trigger that closes the circuit.
The magnetic thing.
Yeah.
Plus, you can get stuff cheaper when it's automotive stuff.
Yep, it's only $7 for a switch.
Go try to buy a 1,000 amp relay somewhere. It's like it'll cost you 10.
Yeah.
Go to the auto parts store, get you a little solenoid that'll handle 1,000 amps for like $10-12.
Yeah.
Yeah, but those can't go very fast when switching, before they go fast.
Oh no,
mine's going fast. Mine's going real fast. All I do
they're not good for high voltage, but they'll for high current stuff that work.
Yeah, but my system doesn't run on current; it runs on voltage.
Right, right.
Like my
Well,
current, my current
solenoids are
coming off.
designed to stay normally closed and then to open
Hey,
up
that might be
for
a good place to get
disconnecting a high amp circuit.
the old relays. Might be a good place to get coils too. You know, they're already wound for you.
Yeah, but you got to go to a large inductor. My coils are minimum 1 pound or bigger.
Or one
Because the
what?
second 1 pound, 24 gauge wire,
Oh,
the one in my big device is over 2.2 pounds. So yeah, big coils are key in my system. Bigger the coil, the better. Because the second you put a higher voltage, instead of using 12-volt battery, I'm working with 25 volts and above. In my big Renegade, I'm using 49 volts. And the second you hit 49 volts of power, hits that large inductor, you're getting huge amount of power.
you might
And
get perking in your battery too, which you don't want.
no, no, because I got diodes for the flyback to protect the battery anyway, so I haven't destroyed a battery yet. So
Oh, I see the thing that
What
might
kind of
help for your
impedance
circuit.
are you got on the coils? The big coil. Was it like 50 ohms?
I haven't even measured it. I
I
figure
wound
it's
a 1500 turn coil, I think it was, and gauge like 30.
yeah.
And
Tesla in one of his writings says, "Don't go by length of wire, go by mass, go by weight."
I see the thing that might make it just like a little bit more efficient. I noticed for your big coil there, you have one of those metal straps going across it. That'll like short out the changing magnetic field a little bit. If you use
Yeah. I know what
whatever
you're
you
talking
call
about.
those,
Yeah,
the nylon ties,
yeah.
a couple small ones, one big one, that might
I got big ones.
work.
Yeah, yeah. You're saying that it affects the blotch wall. Yeah, yeah. I might switch over to that soon. I've just been kind of procrastinating actually doing it. But yeah, that makes total sense. Could affect the blotch wall.
You know, they have some of those in giant. I've got one that's actually this long. It's like almost the size of a belt.
Mm.
I can't even remember where I got it, but I was like, I thought they were only like this big. I didn't know they were like used them that big for what? I have no idea, but
Well, in my big Renegade, I actually made coil holders out of PLA plastic, so they fit really well. And then I just use zip ties to secure it from the top.
oh,
And they're
cool.
really sharp. Yeah, they're really sharp. They're actually really nice. Hold on, watch. Here, let me show you.
How did you make the part that snaps in? When you know what I'm talking about? Because the little the ties usually have like a little metal piece in there for when you tighten it that holds it together. Did you like add like a little piece of metal in there, or just make it
No,
all plastic?
hold on. It's all plastic.
Hmm.
Just give me a second here.
Man, it's amazing how some of those work. I've seen one where they made bearings out of it. It was
Yeah.
all 100% plastic and it worked good.
Oh yeah. Like in the middle of my wheel there is ceramic bearing. Always use ceramic bearings. Don't use metal bearings because the field is actually big enough to actually slow down the wheel.
Yeah, that was who I was thinking of with the
So
Dave
these are the
something from
coil.
Texas.
These are the ones that I was talking about that I made with
Yeah,
3D printer.
I was. Yeah, Norman Wootman, or I think
Hold on.
that's how you say his name.
Hold on. There.
I was thinking there was some guy named Dave that had a very similar circuit too,
So
or he was
the
involved
inside
in
of
it.
my that's the inside of my big Renegade. So you can see the coils. Each coil is 2 pounds. I got four of them. See the 3D printed ones? See the holders?
Oh, nice.
So I designed those myself.
Is the little there's like little band is there? What is that for? Is that like an optical sensor or something?
Which one?
You have like these little rectangles
Oh, those
on
are
the
just
wheel part?
lights. You see when I spin the wheel?
Oh, okay. So you can. Okay, I got it.
Yeah. I just put them there so when I start spinning the wheel, I know the coils are active.
Right.
Like just by spinning by the hand. Look.
It'd be good if you got one of those optical tachometers too.
Yeah, every time I buy one, they don't work.
Nice work, Mike.
Just
Can I
use it
get
on
you
your
to
main
build
hub
me
there.
something?
Your
Just a
main
nice
hub you
work,
got
yeah.
on the top.
This is what I do for a living. I build stuff. Right? I'm a machinist by trade. So
When I
Oh, that
first
comes
built
in
my
handy.
first lab, I was just a mess. But the purpose was a learning purpose. And then my next lab is going to be nice and tidy. And
yeah,
because
everything's
whatever
all
I build is going to be, I know what I'm building, so I don't have
so
to
everything
learn anything.
everything inside I tried to make it glow in the dark, so yeah, so you can see everything. But it's a pretty big device. The whole
Look
device
like
weighs
Bernie's
over.
place.
You 3D printing your parts?
Yep, I do that all myself. Yeah,
Well, you have
everything I do.
to use the AutoCAD and the
Yep.
3D.
I use AutoCAD Fusion. I use AutoCAD Fusion. Then I put it
Well,
into
maybe
a
you can help me
slicing
with that.
program.
I don't want to learn that,
Yeah,
man.
yeah, I'm a pretty much an expert with CAD Fusion. I know that thing inside and
Is
out.
that the free version?
Well, when you buy it, the printer it probably comes with an
Fusion.
AutoCAD program, no?
No, it doesn't.
AutoCAD's got some like free version that's
Yeah,
like
yeah. You have Fusion. Use Fusion. That's what I'm using. I
you have
just
to learn to use it.
what you do when you register as an inventor or a student, and you get the full software for free.
Oh, it's not limited.
Yep.
Damn,
Yep,
that's nice.
that's why I use it, and it's super easy to use it. I love that software. It's awesome, so powerful. You can make anything with that thing. And the
Yeah,
best part
man,
of
last
it,
time I used CAD was for making circuit boards, and that's been a while.
yeah, it's just incredible.
But I used to work at a place where we made circuit boards there, and I had to check work. And oh, you talk about not fun. Had these little 13-inch back when we had VGA monitors, like 13-inch.
Yeah, so right now
I was about
my
half
work,
blind at the end of the day.
at my work, I work on the OMAX water jet system, the 6120. It's a very large one. So I could cut parts from there and cut wheels out and everything. Oh, you've got Norman's device up there, Norman Wu-Tang, which I've corresponded through email with this guy. He tried to get this design patent back in 1992, and the U.S. Patent Office actually seized it.
This thing?
And yes,
I heard that. I
yep,
didn't know if that was true or not.
yep, it was seized. I spoke with Norman personally, so I know the story. So him and his partner came up with the device. This is basically where I got the idea of the piezo transducer. That's what he has there. It's a barium titanate. That's exactly what I used in my system, and it was the game changer in my system. And he was
Hey,
getting over
close
Unity
focus.
with it. And the second the patent office took a look at this thing, they said, "Okay, this is going bye bye." And it's been
Adjust
stuck in the
signal
patent.
source 20 to 40 kilohertz on an inductor with 350 turns of magnetic wire, 3 to 3 transformer.
Have you tried to tune your motor speed to get rid of resonance?
Or is that
Oh,
a
it
150?
well, the transducer puts the coil in resonance right away.
Right, right.
Without the transducer,
All these devices are so basic.
they are
in their
100.
in
Yes,
their
exactly.
the way they're
Exactly. The second I put the transducer in my system,
it's like
my
they're lined up in a
efficiency-
row or something.
Yeah. Yeah, this one
From
was
input
seized
to
right
output,
away.
from input to output.
Yep. This device, I've actually built this
And
exact device.
the coil is always the one thing that's on before the output that seems to be
Yeah,
the
and the
game
one he
changer.
made. Well, no, the game changer in this circuit is the piezo transducer. That's
Yeah,
what
but you
makes
still
it
need to
work.
be able to transform that with the coil.
You without the transducer, that thing's not over unity. As soon as you put that
But
transducer in
still,
there,
the coil is what brings it back into our usable.
right? But the
Uh,
thing is, that coil, the original coil of
see how the
the
transducer is in series with the coil?
right.
It's
But
on the
just
either
just
it's on the top half of the sine wave or the bottom half. I'm not
yeah,
sure.
yeah. But just listen to me for a second because I've spoken with him personally and I know
Square
exactly
wave
what's going on.
will not.
So
What does it say?
so that
Approach
transformer, that
unity. Square
transformer,
wave will not approach unity. What does that mean? The bottom there. Sine
unity
wave output. Square wave will not approach unity.
exactly. Listen to
What
what
the
he's
hell does that
saying.
mean? It will not approach unity. What are they talking about?
U-
Unity.
Unity, meaning it's putting equal power in and getting equal power
Equal
out.
out? That's what they mean by unity? Oh, okay. Right.
That's
Excuse
unity.
me.
So basically, you're at 100%. Anything over 100% unity is now going into over unity. His system was, I think he had MIT test his device or Georgia Tech. Sorry, Georgia Tech. It was registering 118 over unity. 118.
1 to
So
18 or 118?
So again, then I guess
118.
square wave will not.
Damn.
100. Yes.
Uh,
118. He had it tested at 4 reputable engineering universities in the U.S., and they all basically said this thing's over Unity. Now, all the universities would not sign off on it because they know they would get a shitstorm in the electromechanical community claiming over Unity device. They would not sign off on it. One of them did, and they took that to the patent office. And as soon as they had that letter, they had the patent there, they seized it, and it's never been seen again. Yeah,
Yeah, they
it's
won't even
gone.
look at anything like that. I'm surprised.
It's
I don't know.
gone.
Are you familiar with Clayton
you can
Hines,
seize a
the
patent.
microwave? He
Yes,
was
they
at the
can.
Ottawa University.
They can
Yes,
They
seize
they
a
kicked him
can.
patent.
out when they figured out what he was doing.
Yes,
Isn't
they
that the
can.
point of patenting? So that nobody can seize it?
No, no, that's the whole. That's the whole bullshit uh, thing with the patent office. They have the right to seize any patents that see a problem that could cause a problem to
All right.
national
Okay. So you
security.
take your patent
Hold
to
on,
another
hold on.
country.
Let me. No, it doesn't
If they
matter.
seize it, you go to another country. That's all. That's
No,
the whole
because
point of seizing it. So you can't use it in their country.
it's been
And
seized
basically,
worldwide.
once they seize it, it makes you violate federal law by taking it anywhere or even mentioning it.
Yep.
Within that
Yep.
Yeah,
federality, it just means
it gives you a gag order that you can't discuss it to anyone, including your attorney.
Mhm.
It's
Yeah. Oh,
I
yeah.
don't know
It
about
is.
that, man.
really messed up.
I don't
Yeah, it
know
is.
about that.
It
I'm not a
is.
lawyer. You're not a lawyer. I don't know.
From what I
This is what I've heard
understand,
from other people that have had it happen to.
I,
And
I
the
from
tend to
what
there
fly
was a
with
lawyer that
common
was talking
law on
about it.
all things.
from what I
It's common law.
understand, can I tell you the story because this is coming from him.
Oh yeah,
So
please.
I'll give
What
you
was the
guys the
guy's name again?
facts. Norman Wutan.
Wu-Tan. I've heard his name before.
Yes, he's been around for years. This guy is. If you want to learn about over unity, this guy is uh, second in line to God. Okay,
I mean, look how
but he's
basic
still.
that circuit, that device is.
This guy
It's
has made
even more
stuff that
basic than the Don Smith
this
setup.
this guy is so far ahead of everybody that's out there right now. The knowledge this guy has is scary. Okay, I've spoken with him. I know exactly what this guy knows, and he is so far of everybody else in the industry. It's scary. So he was the one that got me to use the transducer, and then I showed him my results, and he goes, "Very good, Mike. Very good. Keep going. You're on the right track, brother." He says, "Keep going."
Are you in
Sodium
Canada?
ferrite
Are
magnet.
you
Yep,
in
we're
Europe?
just
He's got his
I'm just
transformer
outside
is
of Toronto.
Oh, okay. I was going to say, I was
clockwise,
surprised you didn't get a visit by
counterclockwise.
the
So we're
feds.
burying him.
Yeah, I'm just outside of Toronto. I'm very close to Hamilton, Ontario.
You guys see
I'll look
that?
that up.
The
Yeah,
transformer is
Yeah.
The
Oh, that
winding,
transformer.
the
Okay.
primary winding
Yeah.
is clockwise and the secondary is counterclockwise over the barium. And then the
Yeah.
secondary gets bridged, rectified to
Yep.
DC.
I modified my circuit to make it my own. See, I run mine
And he
parallel.
just puts the transducer in series on one half of the sine wave. I don't think it matters.
Yeah. Yeah.
Which half?
I put it in parallel.
Yeah, with that circuit, you're barely feeding it anything because
Oh yeah,
I
it's
mean
nothing.
you're feeding the piezo, but when the output's not on,
Adjustable signal source.
it's an open circuit. So
That's right.
because it's in series with the signal generator.
Yep.
Sine.
The key
If
is
it was me, I would do like
you.
you did and put it in parallel
wave
with the
output.
transformer.
That's how
That's a
I just
much better
changed the
arrangement.
circuit. Because I
Yeah,
showed
much better
Norman.
arrangement.
I
Wait,
showed
Mike,
Norman.
is he square waving this and the transducer is converting the square wave to a sine wave?
He is using an old
Because
Hewlett
it says
Packard.
sine wave output. See, it says sine wave output. And
Like-
look, it says
You have to have a
square wave
sine wave
too.
in too.
He even lists in there what the signal generator is using. Is
He's
using
putting
an
a 40
old-
kilohertz square wave, and the transducer
Okay.
is converting the square wave to a sine wave.
Yeah. Can you listen to me for a sec?
That's
He's
okay.
using an old Hewlett Packard audio signal generator, the old ones, the ones that are vacuum tube. It's like
Oh, wow, that
40
is
years old. Yeah, he's using. I don't know the model number, but I think in that paper that you see there is what he was actually using. So he's using an audio signal generator.
Man, even the ones from the 80s are expensive. I wanted to get one of those 3325s. They're like $300.
I have an old amplifier that still works. It's from the 80s. I don't use it. Been in the boxes for years. It's a powerful one too.
I can tell you a cheap way to get like a really accurate one if you build a circuit is use one of the GPS. What's it called?
40 kilohertz square wave.
The GPS timing version. Because the one on that, I think mine was like U-Block 6T, I think it was. I think I paid like $8 for it. And besides having I can, once it locks to the satellite, it's basically like extremely accurate standard, and you can tell it whatever frequency you want to put out. The only thing that's kind of a disadvantage is, you can't like tune it like a dial. You have to put in an exact number each time.
What are you using to generate with?
You know what I suggest to everybody? Okay, the first thing I suggest to everybody: these guys are way ahead of everybody else. Okay, so you take that circuit and you build it exactly the way he built it. Don't think you know any better, because you don't. You
Norman,
build
what's
it
up?
exactly. You build it exactly the same way Norman built it. If you do that, you're going to see the effects. Then after you understand, yeah, that's what I use. Barium type.
Barium ferrite magnet too. I completely missed that.
Right. He's got the primary winding from the 40 kilohertz square wave that's being converted on one half of the square wave by the transducer in series with that one half of the sine wave is converting it to that one half of the square wave. No, he's converting the top part of the square wave and sending the bottom part of the flat line of the square wave down the bottom. And at the top, he's probably sending out the top part of the square wave through that transducer in series to the primary coil.
Now, he also told me the transformer in the original circuit he made was
But it says sine wave output, so that something is converting the square wave, so it must be the transducer.
Yeah,
he's got a bridge on it too.
The transformer.
The way it's wired, it has to be the transducer.
Can you guys hear me?
Yeah, I hear you.
Yeah, go ahead.
Yeah, I'm trying to. Yeah, no, I'm trying to say something that I don't know if you guys.
There's a little delay that kind of makes it difficult.
Yeah, I'm outside right now. But anyways, the transformer that he built, he said he made very crudely. It's a very inaccurate. The windings are not perfect, and even though that his transformer was only about 50 or 40% efficient, he was still getting over unity. That's the crazy part. So you could use a really bad transformer and still get good effects.
How much of the output was due to the piezo transistor, and how much of it was due to the transformer?
I think the
I would say,
piezo was converting the square wave to a sine wave, and that's where the
yeah,
gain came in.
yeah, exactly. You got it.
Because you're
That's
going
exactly
digital to
what they.
analog right there. You
Yeah,
know,
yeah,
That's right.
but the gain though, that's what I'm talking about. How much?
Well, the piezo
digital
makes
to
it
analog
happen.
is probably a gain in its own. Man.
Yeah,
The
the
piezo,
piezo would, but with the, I mean, there's clearly a reason he used the barium ferrite magnet.
yeah,
Oh, he sent the
And
digital signal onto a analog piece of matter that's made out of barium. Well, also the barium
yeah,
core. See, the
but
piezo is
in any
also barium.
transformer,
There's two barium elements here, the core and
any
the piezo.
transformer and bridge would have converted that.
It's just a vibration, though. The barium's vibrating, by the way.
Yeah, that and
well,
he's got
he's
it
making,
1-to-1
he's
too.
making, he's putting the transducer. Everybody doesn't understand the transducer. When you hook it up to a transformer of any kind, it puts it into harmonic resonance right away.
Right, he's got it hooked up in series with the transformer, right here.
Yeah, yeah, he's got a little different hookup than I do. But what I'm trying to say is the transducer is what makes that coil go into harmonic resonance. Since that's achieved, you get over unity.
Yeah, parallel makes much more sense
To me, it
than have
does.
the
But
signal generator pulse it.
I've tried it both ways in my system, and it works either way.
How
It's
big
like a
was the
two.
original? Oh, sorry. Go ahead.
I guess if you can get
Like,
the barium matter in the circuit any way you can, it's probably going to move your work.
yeah, when
How
you
big was
start
the
getting
original transformer? The magnet and
it was tiny. It was only about 1.5 inches, 2 inches long. It was a tiny.
also it was one of those little
tiny,
bitty.
Yeah, it was a tiny thing.
It's a barium titanate piezo.
Yep,
And a
that's
barium
what I
core
use.
is barium transformer core also.
See, the core in my coil is I use iron welding rods because they have a very low carbon content.
Was it
And
something
because
like
of that,
these? The like kind of get like at Radio Shack or Harbor Freight, the barium titanate, or the barium whatever you call it, or ceramic, some version of ceramic, but they're fairly strong.
yeah, it's a ceramic barium ferrite, or sorry, barium titanate.
Yeah. These are at Harbor Freight for like $2 for $1. They were like $3 at Radio Shack a few years ago.
Yeah, the ones
I
I
think
have
barium
are,
is probably a very good piezo material. That's
yes,
vibratorial.
yeah, it is by nature. Yeah.
Like quartz, probably.
Yep.
These things aren't as strong as like the Neos, but they're
I had an
still pretty
idea.
strong.
I had an idea to wrap a coil around quartz.
Yeah, I've done it.
Using quartz.
Problem is, you're not getting enough induction.
Well, maybe you are. You're just not getting flux. You're getting something else. You're not getting iron flux. You're getting quartz flux.
Yeah, that would run
You know,
at very high. That would run at a very high frequency.
If you took that quartz, hooked up
a
a barium, the transducer to it, you've got your own crystal oscillator there. But since it's so large, you might be getting over unity there too. You know, basically making a giant quartz crystal.
Yep.
And especially if you keep it under pressure. Jeremiah was saying something about that he got some rocks where he was getting pretty good sized sparks off the thing. That what do you call it? Purple rock.
Oh yeah, yeah. I got what do you call calcite quartz crystal. Has a higher carbon content in it, and they work really well.
Yeah, that's digging into the the chemistry of each element and the number of electrons, protons, valence electrons.
Well, it all boils down to the materials that you're using in the circuit. Like as soon as you understand the circuit and build it exactly
Charges
the way
and
you already
polarities.
built it, then you can start experimenting with core types and wire thickness and putting diodes in there. Then you can start experimenting with different elements in it. Zener diodes or Schottky diodes, or and
I wonder if you could get one of those, whatever you call those grills, the like propane grills that people use, the little igniters out of those, and you get the crystal out of it.
yeah. Well, you can order them online. I got a whole bunch of quartz crystal.
Yeah, even Walmart has them
Propane
for like
grills have
maybe
crystal
$5.
with quartz in them.
I got tons of quartz.
Yeah, that when you press the button and it makes a spark, yeah, that's a quartz crystal in there.
Oh, is it the igniter? I didn't know that.
Mhm.
I thought it was like a piece of iron or something.
Nope.
Same for those little cigarette lighters ones, the ones that click.
Yep.
Mhm. Were they rubbing two pieces of quartz together with a spring or something?
No, they're smashing into each other.
It's like a little lever
You
mag.
mean the thing you push
lever,
the
and then it
pop, it makes a spark?
Yeah, or
it-
they have like a little pin on
It's
it.
like a little
There's a
hammer
spring in there,
inside.
isn't there?
It's like kind of like the hammer on a gun, right? It just hits it hard.
Some kind of
That's-
spring in there. It must rub two materials together. You're saying those
No, it
materials
doesn't.
are quartz?
No, it doesn't rub. It hits it. It strikes it.
Oh. It strikes.
That's when you get the voltage. Yeah.
And it
not
strikes quartz,
friction, it's like,
quartz on quartz or quartz on what?
Quartz on a
Quartz
piece of steel.
On
So
steel.
all you do, I've
Oh.
seen guys.
And that
do
sends a spark
circuit-
through the steel. I get it. Okay.
Oh yeah. Oh, it doesn't matter.
Yeah.
Like it-
Well, let's say you just had had one of the rocks here, and you just had two plates on it. If you just take and come along and you hit it with the hammer, you'll get a.
Yeah, you get a
You
spark.
might get a couple thousand volts out of that.
Well, why do
for
they
a
use
split
quartz?
second.
It's just easier to make a spark with quartz than it is to hit it with two pieces of steel. I guess.
That's right. Yeah.
Huh.
The quartz is
Yeah,
where
it's
the
that-
power's coming from.
That's the whole piezoelectric effect.
That's right.
I thought they
That's
would have
where
used
it-
magnesium or something. Maybe that's just too flammable.
No,
Yeah.
magnesium.
If you've ever heard of earthquake lights, that's one of the things they think are coming from it, because you've got that underground and you've got all that pressure shifting.
Yep.
Where you can literally get
Actually-
lightning from it.
Yeah, even salt too. If you go to a salt mine,
Yep.
you'll see light. You'll see light coming from the salt. If it's under pressure or whatever, yeah, it'll make light.
Boy, that'd be pretty cool looking. You turn off the dark, turn off the lights, and
Yeah, it's
Play some
really
music
cool.
on it.
So he
it'd be like a little
rectifies the
fireworks
AC.
display.
And Tesla was working with quartz crystal quite a bit in his later years, doing a lot of experiments with the piezoelectric effects. He says quartz crystal is alive; it's a living being.
See,
That's
right there where the
pretty cool.
rectifier is, on this circuit here, you would put the hot and the neutral of the grid, or you to your breaker panel. Just run your house. Don't rectify anything.
Hey, what kind of
The
voltage
problem
is
is your
was he
device
getting out of that
can't run
circuit?
off of 40 kilohertz.
Well, I was getting enough voltage to power up 8 LED lights. It's about 40 watts. Not fully illuminated, but I was able to get them all lit.
Hey, Anthony,
I
if you
built
were to
that.
step down 40 kilohertz to 60 kilohertz, is there some easy way to do that?
You mean 60 to
Up
40?
40 kilohertz to 60 hertz,
Oh,
or you know,
Well, you're using your signal generator. To
right here
establish-
he's using a signal generator to get 40 kilohertz.
Yeah, you can just.
or if you're trying to do it for timing, you mean? You can do
Mike,
that
your
digitally.
Renegade had the piezo in parallel, and you were able to step up the frequency.
If
Yeah.
you're trying to make power out of it, it's easier just to convert it to DC and then run it through like a switching power supply or an oscillator.
That's
If you
what I'm
actually just
saying.
want to
Why
do
not-
it for
why
timing,
put
then
the
you can do it
rectifier
digitally.
there? Why rectify the output when you? When
Well,
you
because it's a pulse. Because when it goes through the transducer, and then it goes through the
yeah, but the
coil.
power doesn't get used until there's a load, and
It's crazy it didn't have a capacitor in there too.
You don't use a
Yeah, no,
rectifier. You
that's-
put you put it right to your breaker panel on the hot and the neutral, and you run your house off. But you don't need to store the power.
Oh,
The thing, no. You gotta
it's
have it at
Store the
60
power on the
hertz.
output. You store the power on the input.
the low level DC is way easier to work with. That's
Right. The
you're only
only
getting
reason is
pulses out
because
of
it's
it.
40
AC stuff
kilohertz. Because it's
wouldn't
40
run.
kilohertz, I get you. But is there some
The,
easy way to step down the frequency?
well, it depends
Yeah,
on
well,
the frequency.
just use this circuit here, and then convert it to put it through an
This circuit
inverter.
doesn't convert frequency. It starts with 40 kilohertz. It doesn't change the frequency on the output.
Right.
It
But the bridge, when it goes to DC,
it uses the
you put
bridge
the
rectifier
capacitor
to
across
change the
that, and then you
frequency.
convert it to whatever you want.
Right.
That's how
But when
switching
you
power
do it,
supplies work.
when you
Inverters.
rectify the power, you lose a lot of energy, and you can't.
You're only losing a little bit by rectifying it.
See,
I mean,
if
Yeah, but
you're
you
only
when you,
losing 0.6, 0.7 volts out of 120 volts. Or in this case, I'm guessing you said about 40 volts. So
yeah, but to rectify it, you
you're
also need
losing basically.
storage.
Yeah, the storage is you're losing more there, and because the batteries are,
And
I
if you
think it's
don't
like
you have to
around
throw if you don't have
80%
to throw the
efficient.
power
So
into storage at all, and you only use it when it's being demanded, then the source will not feed power. The 40 kilohertz source will not feed power until the circuit demands it. So where's the loss? When you have the rectifier, you have to store all that energy into
there
a
you go.
yeah,
storage.
this
No,
circuit here,
you don't need to store it to
this,
rectify it.
If you rectify, you need to store it.
No, that'll run just like he's showing. See, it goes from the transformer to the bridge. The bridge is
Okay.
rectifying. That's bridge rectifier. That's four
So
diodes
your load is DC
together.
then.
Yeah, it's actually that circuit there would be like a pulse DC output, but you just hook a capacitor across it, and you've got a it may not be a perfectly filtered circuit, but it's
And then you go
good
from
enough for
DC
most
back to
things.
AC, is what you're saying?
Yeah, then you can convert it to AC or whatever you want.
DC back
you
to
have
AC.
you have to dump that potential to put it into a capacitor.
Okay. We thought we lost you.
You have to put it in a
Son of a-
capacitor. So you have to put that circuit directly into a capacitor bank. From there, you can do whatever you want with it. You change it to AC, DC, whatever you want to do. But the important thing is you cannot run this circuit directly into a load. Okay, if you do, you kill the dipole, and the system will crap out. Has to be all the load.
Okay, then what I would do with the rectifier part is I would use it to pulse drive a flywheel, which would then spin an alternator.
Yeah, but you have to put it into a capacitor first. You have to create a reservoir of power, right?
Right, I'd
So
use
you have
the
to-
rectifier to pulse to drive whatever, store some of it, the energy to pulse drive a pulse motor, spin up
Exactly.
a flywheel, which would then drive a three-phase alternator.
Right. So that's exactly what my system's doing.
And as you turn your lights on and your devices on, it pulls off the alternator real time. The wheel just slows down a little bit, just a little bit.
Yeah.
It goes.
Not only that, you
The
can use like
flywheel.
the Thane-Hines in it to divert the back EMF. So
Well, converting the back EMF is.
no,
is
I
that
don't
what
need the
this
back
thing is
EMF like they're
or-
doing here. They're using the back EMF here. What I'm talking about is on the motor itself. If you load down the motor, the back EMF will draw more current from the battery. The way
That's right.
Thane-Hines is doing it is he is physically rerouting it to a different part of the transformer. So you could connect a separate battery and then charge it from that, or you could run a separate circuit. That link that I left there for J.L. Nodden, it's on his page where it says the bitoroid. It shows it. He even shows the magnetic simulations for it. The guy's a fringe physicist, and he covers a lot of different things on there. He covers the Thane-Hines, the bitoroid, and the regenerative acceleration. He covers the MEG from Bedini and Bearden, and a few other things. He hasn't updated it in years, but it's still a really good site.
Is it in the chat, the link?
Yeah.
Yeah, the best thing I suggest to everybody who's getting into this stuff, you have to follow the original plans right to a T.
Oh, there it is.
And then as soon as you
I
understand,
put it in again for the private chat. Yeah, there you go.
How do you copy the link?
Just copy and paste.
Oh, there it is.
I put it in the private chat too. I went to do comments, but for some reason it says join the chat, whereas usually it
Yeah, I don't know.
everywhere else it's always just came right up. So I left my old my original YouTube window open and I just turned the sound off.
There it is.
Yeah, there it is on the top of the screen. Yeah, you found it. Yeah, he's got a lot of good stuff there. Yeah, where it shows the BITT, that's where where he's talking about it in a few of the tests. Let's see. I'll put that on the private chat for you. And that shows you the page where basically it's like it's only slightly drawing more power, but it's very slightly. And he even shows a simulation of how it should work, and the versions he's made.
See, the way my system works, you can put the biggest amount possible on my system. It doesn't draw it down.
Yeah, I'll put it back in the main chat so other people can find it too.
My system, you can
load scroll down, or what are we looking at here? A lot of stuff in here.
Are you on the main page or the one I just? Oh, you're on the main page. Okay. See where it says? Stop right there. See where it says BITT15? Just click on the picture. There you go.
This one?
Yep. And that shows you his test results.
Oh, you're talking about the bit transformer?
Although it looks like you might have got the left one, maybe. Don't know how, but let's see. Okay, no, that's the right one. Okay.
You're talking about the bit transformer?
Yep. It's short for bitoroid.
Yeah, I know people that have made that.
Yeah, I've been trying to get some transformer cores together to replicate that. Steel isn't so easy to cut, so I got a Dremel and some microwaves to replicate it. Try to, because I want to make something where I can at least do like 50, 60 watts. Not just like a few watts to where. I want it to be obvious that it's working, not just a little bit of measurement error. That's the regenerative acceleration right there, part of the circuit.
So I guess like the flyback from the yellow is hitting the blue coil, or to stop the lens?
Well,
something like that.
I haven't. I was mainly interested in the bitoroid part, but the way I understand it, I don't know what he's. I think what he's doing here with the three coils is when these have back EMF, which would normally load the circuit.
If you're using the flyback right away somehow into a battery or a coil, there is no lens. If you're not using the flyback, then it's going to turn into lens.
That's right. And
so you don't have to worry about lens. If you got the diode facing out and you're actually channeling it out of there to somewhere else,
because
then
like
don't worry about the lens. It's not going to happen.
Most motors, what they do is they put a capacitor across the terminals.
That's what he's doing here.
Right. So, but you want to funnel that out, that back.
That's what he means by regenerative. What'd you call it again, Anthony? Regenerative what?
It's regenerative acceleration, whereas they used to have regenerative deceleration. In other words, when you hit the brakes, instead of doing that, you would put a load on it, and he would slow the car down by using the motor as a generator and
That's
loading it down.
because those
This does
motors
the
have
opposite.
lenses. That's because those
Well,
motors
it
do
still
not
has
channel the
the
flyback.
lens. Yeah, it's still there. You know, the lens back EMF,
Have
but
lens. Have lens.
it's just diverting the field instead of like using a diode to rectify it. It's physically
Right, or
diverting
you
the field.
could. Right, he's diverting the field into another inductor. Right.
Yeah, and into the part where you see those the three electromagnets on the side.
Yeah, he's in diverting it twice. So one flyback from, let's say, from the, I guess I don't know which one. One
Yeah,
of
the bitoroid does a similar thing. The bitoroid, when you would have the, I mean, when I was in school, we were taught it was one field and it loaded the original field, but clearly they're not, or part of it can be separated. You can look at it either way, but he's diverting the back EMF field when it's a transformer by having a separate section of the transformer, and just here by having a separate magnetic field to track that part out. So it's an interesting way to do it.
And then use it to drive the motor as well.
Well, for the motor is using it to recharge the battery, and then reuse it. And for the transformer, you can do it either way you want to. To either recharge a battery or to use it in a separate circuit.
You can also
you can have it like two separate batteries, like your other circuit there. There's a lot of similarity there. So the way I think of it, I've got like a whole collection of different patents. I just call them flux switchers because they're basically moving around what the flux does. Where they, when I took electronics, they never even mentioned that, but it's more of like a physics simulation thing. It's not normally used, but these all the principles. I tried it just with magnets and switching it, and it works. So I just want to replicate it and see exactly how efficient I can get it. But you can see where he's did the tests, and he's got his graphs there, and he shows the exact parts list and circuit setup. He did a really good job on these. I wish everybody would show their experiments like this. Between here and that Rex Research site and Patrick Kelly's site, they're like by far the three best sites on the internet I could find for all different kind of patents and technology. The Patrick Kelly, the free energy devices, he made the patents a whole lot easier to understand too. He like colored different areas and everything, made them way easier to understand. Yeah, he just like passed away, I think, a couple of years ago, but the site still exists for now. So get it while you can.
He passed away.
Yeah, man, he must put a ton of work in it. It was like over 3,000 pages just a few years ago, and then he made like a shorter version. And it's like I don't know if you've seen it or not, but it's like very well laid out into categories.
Yeah, I've seen a lot of his stuff. That's where I got some of the other ideas from the original Adams motor design.
Mm-hmm.
Yeah.
Did you replicate that too, or?
Well, I put my own flavor on it because I understood his concept. Like when I built the motor originally, I didn't even know who this guy was until later. And then I looked at his circuit and I go, hey, that's pretty much what I'm doing.
Did it take like 45 seconds or so to build up power before it started working when you build it? Like the Adams?
Mine's instantaneous. It starts right away. There's no buildup. It just starts automatically. There's no delay in time.
Because I know the Adams, he was saying it took time to charge it up, but...
Well, it depends if you got a lot of capacitors in the circuit that you have to charge up. I like to run it personally, I like to run it just to condition the motor, get everything up to speed and,
Mhm.
actually. So he's using the
I don't know if
outrunner
this shows a link
motor.
to it, but YouTube used to have the Thane Hines um, original videos where he's like in a college setting and showing how everything works. Let's see.
So he's using an outrunner motor. He's spinning magnets inside that core.
It's the
Yeah,
original
it's a-
core.
No, but like what he's spinning on the inside with the motor running. Is he spinning like a set of magnets inside the core with the outrunner motor? Seems like that's what he's doing. Okay, I see what he's doing.
Yeah, that's just the
Yes.
original motor. The only magnets are added to the outside, the electromagnets.
Right.
Oh, they were okay.
So he's spinning an alternator with his
Yeah,
electromagnet.
that's basically what it is. And the spinning magnets on the inside, that's what's creating the current in the motor
He's
or
spinning
in
an
the
alternator with
core.
his electromagnets.
Yeah,
Pulse
he's
motors.
just gonna. Yeah.
And by
Well,
channeling
no,
the flyback on the pulse drive
he's
part,
actually he's using a drone motor to actually turn the magnets inside the core. I could tell just by the sound of it that he's using the drone motor.
No,
So
that's JL Nod, his version. That's
yeah.
where he replicated some of the effects. The Thane Hines originally didn't use magnets at all in the core. He just added them externally.
Mhm.
I added the link to the video of where Thanes originally put it from the college. Fortunately, it still exists. And it shows where he added it onto the transformer.
Did he get kicked off YouTube?
Some of the videos are gone, but I don't think he was actually kicked off. But it's hard to tell. Because originally, I think the channel was just Thane Hines, but this one now says Thane Hines 2022. So I don't know if his
So it's-
original channel was kicked off or not, but this shows the actual principle of it working.
Mhm.
It's in the private chat there. I can put it in the other chat if you want to
on
hear.
the private chat. Hold on.
Yeah, I didn't know which one was easier to see. I'll put it in both.
Oh, that's Thane Hines. He's the guy who did the two motors, right? The belt-driven setup.
Well, there's the bitoroid, and then there's the motor regenerative acceleration. They're like two separate technologies, but they have a lot of some. They divert the back EMF and of the system in both cases. Just a little bit different way of doing it. We're like I've heard. I can't remember if it was him or somebody else, but somebody called it a magnetic diode. I don't think that was him that called it, but it's a similar idea, basically. Yeah, there's also a patent out there called transformer in combination with a permanent magnet that does a similar thing.
Today we're doing a update video on the
Can you hear the audio?
bitoroid transformer.
Hmm?
So the bitoroid transformer is a new type of transformer that uses purely reactive power in the primary, but delivers real power to the loads. And here we have the output of the transformer. Can you come in and just so people can see that here we have the voltage across our two light bulbs and the current flowing through our two light bulbs, which indicates there's power being sent to these purely resistive loads, and our power factor on the primary of our transformer is 0. It's fluctuating. It's obviously not 1. And down here we have the current and voltage sine wave. The red sine wave is the power sine wave, and this shows that the power that's coming. Hello, my name is Thane Hines, president of Potential Difference Inc. And today we're doing a update video on the bitoroid transformer. So the bitoroid transformer is a new type of transformer that uses purely reactive power in the primary, but delivers real power to the loads. And here we have the output of the transformer. Can you come in and just so people can see that here we have the voltage across our 2 light bulbs and the current flowing through our 2 light bulbs, which indicates there's power being sent to these purely resistive loads. And our power factor on the primary of our transformer is 0. It's fluctuating. It's obviously not 1. And down here we have the current and voltage sine wave. The red sine wave is the power sine wave, and this shows that the power that's coming in on one cycle is being returned back to the source on the other cycle, and the voltage and current are 90 degrees out of phase, which means that the power factor of our primary is 0, and all of the power that's being consumed in the primary is reactive power, meaning the net consumption is 0. So here we have the bitoroid transformer with the primary in the middle. We have secondary 1 and secondary 2. Right now the 2 secondary coils are on load, and the secondary induced flux from secondary 1 travels into secondary 2 in this direction, and secondary 2 does the same thing. There's no flux, no secondary induced flux coupling back through the primary, and this is why the power factor of the primary is 0. And so when we put the bitoroid transformer on no load, nothing changes. Or rather, when we put the bitoroid transformer on load from no load, there's absolutely no change in the input to the primary of the bitoroid transformer, and because there's no secondary flux coupling back through the primary affecting the performance of the primary from no load to on load. So we're going to compare this performance.
What he's doing here is the primary is feeding the secondary, which is flying back into the other coil there, getting rid of the flux.
It's physically diverting it. It's physically diverting it.
And using it. It's also in the load. As the load. Loading the...
He's creating a circulation current through...
As he diverts the flyback.
It's moving the flux. It's moving the flux to the second.
Right.
The second.
Well, the primary is being switched, creating flyback on the primary, right? That primary flyback is feeding one of the two coils on the arms, right?
Yep. And then it feeds that flux to the secondary.
And then it flies back again to the other coil on the other side of the arm.
Yeah,
I put the patent up for that. Just having the square and then
And
another
both
larger
those coils
square
on the
is-
arms are being loaded too. Huh?
Yeah, there's no physical connection between the primary to the two secondaries.
Right,
All it's getting,
isolates.
the only thing it's transferring is the flux.
Flux.
And then
Right.
the flux travels the path of the core in a clockwise direction from coil 1 on the right side all the way around, back around to the front to coil number 2, and just keeps going. It just keeps going in a clockwise direction. So
And which coil is he
basically,
loading? Both of them? Both the secondaries are loaded?
well, one of them is taking the initial load first, and then it transfers around. It'll
Right.
naturally pick it. It'll naturally pick its own starting point, and then from there it just creates the current, and the current flow will
So it
continue.
looks
to
like
go in that
100%
direction.
efficiency there, no? At least.
Actually,
I wouldn't say
780% efficient. In tests, 780%.
Really, that's pretty
So
impressive.
he's using the iron core is creating the excess then, the extra flux.
Yeah, because
That's why.
any
That's
kind
that's where that 780 comes from.
Wherever
See,
the magnetic
whenever-
field gets its energy
It comes from the iron
it's,
core, Anthony.
see the iron core is.
Anthony,
if
you
look
gotta
at
check
it,
that's
out
a good possibility.
Robert Holcomb, the Holcomb generator.
It could be the resonance of the iron.
The iron is where you get your over unity.
I put
Yeah,
You need
the
the coil. You need the coil to create the signal, right? But then the iron is it's going to bounce that signal. The more iron you got.
yeah, but just a regular transformer have the same thing. It won't work. You have to divert the flux.
Right. From
I put the 2 patents on the side too, if you want to check that out.
If you don't take the flux out of the iron, eventually the iron peaks out to how much flux it can hold, and then you start losing. It'll radiate somewhere out into the environment if you don't take it out.
well, no, it will be collapsing in on itself, and it'll create an internal
Or that too,
resistance.
right? It can cancel out.
And
Right?
then you get hysteresis involved, and then it's all downhill from there.
So you have to draw out the excess.
Yeah, because it's confined in the toroid. The
See,
toroid.
that's what ringing the bell
confines the
means.
flux.
That's what ringing the bell means. Ring the iron.
The patent shows it a lot clearer diagram than what's on here.
I understand this design that he's done, and the key is, you can't oversaturate the core. If you oversaturate the core, you get into a magnetic lock, and that's what you don't want to have happen. Get a magnetic lock, then things will start to heat up. You're exceeding the limits of what the core can handle, right? Because any toroid core, when you energize it, it's not an open circuit; it's closed. So, if you oversaturate that core, if you oversaturate it with magnetic flux inside the core, that's where problems start. So as long as you keep ringing the bell, like you said earlier.
That never happens though with the Bedini circuit because he's got the diode sucking out.
Well, he's created an open circuit, it's not a closed circuit. It's different.
But the core of the inductor, it still has flux, but it's being removed with the diode each pulse. There's no buildup.
Well, the other thing too is the type of core material he's using. He's using what I use, and that is welding rods. And you cut them down and you make your core material with it, and you basically put a coating, either silicone or wrap it with tape or whatever, to isolate each and every piece of that welding rod, and then you stack them so they're isolated from each other, so the flux won't couple within itself. The idea is after you create a magnetic field, you want it to collapse and lose its magnetism as fast as possible. because what will happen in regular iron, especially if it has too much carbon in the carbon in the iron, when you energize the coil, it magnetizes the iron. But the thing is, when you shut it off, the flux is still there. It hasn't collapsed. The magnetism is still present, and that's what you don't want.
And remind me, this core here is it's barium.
Steel plates, probably. It's barium, and
Yeah,
it's probably steel plates.
That's just a normal steel transformer.
Yeah, so it's steel plates. Yeah.
So being laminated plates, the field collapses faster.
Yeah, they have a pretty good response. There is better material, but they're widely used in industry. It's pretty well standard.
So that's
Well,
why
Well,
they
the
laminate
difference here is you're giving it a second path for the magnetic
There's no
field.
buildup. There's no
That's
buildup like that.
Yeah, that's right. You're creating a situation where you're filling the bucket and you're able to extract power off the other end without killing that field that's inside the core. You're keeping the core saturated to a controllable level that it doesn't go over and it doesn't go under. So it's a very controlled circuit. Seems to be working for him. So he's getting that high efficiency, 700%. That's pretty damn good.
So wait, having laminated plated cores controls the level of flux.
The flux density. Yeah.
And wouldn't it be better to allow the flux to?
Well, he's giving a path for it to come out. So he's created a flux density that's pretty high, but because he's got two cores on either side of the primary, he's got a path for that to come out, so it doesn't get oversaturated, right?
Right.
Well,
You don't really
he's
need
draining.
the
He's
two
draining.
cores
He's
either.
draining with the coils. He's draining the core.
That's right. He's keeping it under control that way. Where a
So
regular
as long as the
transformer-
core has a load, you can saturate it with flux.
right?
Well,
but
check out the patent for that. The diagram is much
point.
easier to understand than that patent.
Otherwise, it'll start getting hotter.
Yeah, you get hysteresis because you got a flux density that's exceeding what the core can handle, and that's when you get the breakdown and the heat starts. The electrons are tied to the core. They're going to start vibrating, and as soon as
If the energy has no output, it's gonna
that's
have
right.
no
It has
output.
nowhere to go. That's right. It's it's going to start to break down, right?
Well, in this case, the magnetic field takes the easiest path, the lowest reluctance, which is the second.
Which
Exactly.
is one of the
Second
two
part of the
coils on the
core.
arms of that core.
You're tapping off it twice. Is what you're doing.
Right. Like if one path is not easy for it to go, the other path it'll be easier and it'll go that way. Either or, it always has a choice. The energy to go either one direction or the other, guaranteeing that there is a drain no matter what.
Yeah, and it's equal on each side.
Right. It is going to be AC to some degree, so you need a top path.
Yeah, this is all AC circuit.
Yeah, it depends what you're pulsing the
Flyback
primary.
is an AC signal. A lot of people don't believe that, but it's got a little bit at the bottom there.
But
So that's AC.
Basically what sets the frequency is the primary coil. So it's going to mimic whatever the primary is doing. You're putting
performance to a conventional transformer, which mirrors the load power factor in the primary. So when we put the conventional transformer on load, we will see a very different power factor. So here we have the conventional transformer is on load. The power factor in the primary, the power factor, can you just show the light bulbs again? The power factor of the load is 1. That's transferred back to the primary of the conventional transformer, and it's reflected in the primary. So now we have the voltage in the primary times the current in the primary times 1, and we have real power being consumed in the primary of our conventional transformer and real power being delivered to the load. And if we look at the sine wave, we can verify what the meter says, where the current and voltage are now in phase. The power sine wave is all above the middle line, denoting that all of the power that's being consumed in the primary is real power and that the power factor is 1. So now I'll put it back on the bit again so we can have a quick check here.
So this whole thing is AC.
Mm-hmm.
It's not there's no DC source here?
Nope. Just power coming in.
So there's no Flyback either.
On load again. Sorry, we have power flowing to our
This
loads.
is all a flux machine.
The power factor in the bit is 0, and you can excuse that that meter fluctuating. That's the
just manipulating the magnetic field
voltage, which is
it's still a type of a bounce though.
That power factor to jump to 1, but it's obviously not 1. So we're using this meter in conjunction with the oscilloscope to confirm that
that's just normal sine wave.
Both meters are saying the same thing, and in fact they are. So the conventional transformer,
so the primary is being fed
load,
AC.
It's consuming reactive power. When it's placed on load, the primary then consumes real power and delivers real power. The bi-toroid transformer, on the other hand, when it's on no load, it's consuming reactive power, and reactive power means that pure reactive power has a 0 power factor.
Anthony, you never built this thing?
We have in the bi-toroid transformer on no load.
I've got the materials together, but I haven't put it together yet.
There's absolutely no change.
The house has been too much of a disaster to do it.
Sending power to our load, and the primary of the bi-toroid transformer is completely unaffected. So to go
what do you
over
give it,
just
like
a little bit of
100 watts?
transformer basics for you.
Puts out 500
Here we
watts or
have
something?
the conventional transformer that is on no load. There's no load connected to the secondary.
Whatever you design it for.
Primary delivers.
I'm guessing if you use like a microwave core, it could probably get like
and
at least 500 watts out.
Secondary. The
maybe 1,000.
Primary voltage and current.
But it's not possible to loop this thing. You have to break the symmetry, like Mike said, and then create a new sine wave.
And the power in the primary.
No, you can loop this. Yeah, you can have the first one feeding a second one, feeding a third one.
Yeah, but you can't loop from the source.
I would say start them one by one, but because otherwise the first instant you would load it down too much. But as long as each one is started, maybe one, then wait a second, the next, you could do 100 output from one end.
Things occur. First of all, the secondary coil of the transformer has current flowing in it, and
this is a regular 2-wire,
which couples back.
No, but on your output, your load,
this magnetic
your output's 2 wires.
Lowers the impedance.
Right, but on one of those wires, you put your loads in series.
The primary current to increase. And
this would just be a normal output like everywhere else. The difference is how the magnetic field's used.
A conventional transformer is
right, but if you want multiple loads on that one output, you put the loads in series on the hot leg.
So when the conventional transformer is on load,
no, you put them in parallel because you put them in series, the reactance. would lower the
And
voltage on
the
each one of
power
them.
consumed in the
Well,
transformer
to do the Tesla
You would
one
end up with
wire,
so
you
much
would put it in
induction.
series.
is real power.
If you put them in series, the
It
inductance
has a
of each
real
one would
cost
add up,
associated
and
with
you'd
it.
end up with
That's
Now,
the
the
right. That's the
bi-toroid
Tesla
too
one
low
wire.
voltage.
What I'm saying.
is very different
In
in
series.
its operation.
That's the
on
Tesla
no
one
load.
wire system.
Here we have a bi-toroid transformer that's
Yeah,
on
you
load,
wouldn't
but
want it
on
in
no
this
load,
case. Yeah,
the
you would
primary
want them to
delivers its
Parallel?
flux
get the in parallel,
both of
have
the
the full
coils
voltage in this
simultaneously.
case.
When secondary 1 and secondary 2 are placed on load,
So you have your amps
the induced flux
evenly
from
spread out
secondary 1
that way.
does
Yeah,
not
in this case, it draws very
go
little.
through the primary.
Just
It
maybe like the
travels
first split
in this
second when it
direction
first comes
through
on.
secondary 2, in this direction through secondary 2.
I-
That's all
Secondary
because of the
2
two cores.
does
You
the
have a
same
core
thing.
inside of a core.
So we have
That's
Right.
zero flux
so
coupling
So you see
back
the
from
top and the bottom
primary,
where the extra
and this
little
means
space
that
is
the load
on the
power
very top.
factor
There's no coil.
cannot
You can put
be
extra coils on there on the
transferred
top of the
back
bottom
to
too, and
primary,
get extra power out there
and
too.
the current
Right.
in the primary does not
If
go
you
up
needed to.
when the bi-toroid transformer is placed on load, because it's
I'd like to get a hold of
it's
a
only the
three-phase
secondary
transformer, and
flux when coupling back
He's
into the
pulsing
primary
AC on the
differently
center
there.
part of the
change
core. The
performance
top half
the,
of the sine wave is going out
primary
to the
from
right, the bottom
no
half
load
is
to
going
on
out to
load.
the left.
In the bi-toroid transformer, because
Something like
there
that
is
is going
no
on there.
secondary flux in
Right.
the primary, the voltage and current are 90 degrees out of phase, and the net power in the primary is
Well, how did he line up them
zero,
back into phase
and the
again?
bi-toroid transformer uses
that's just
pure
how the
reactive
transformers
power
work normally.
in the primary.
Yeah, it's
Oh,
because the
normal
inductance of the
transformers are in
it's
phase?
because the
loads,
it's because of the inductance of the
whereas
transformer,
conventional
not the
transformer
nothing
What's
that
the
he did.
purpose of
uses
having it 90
real
degrees out of
power
phase?
in the primary and delivers
He didn't
real
do that.
power,
That's just what an inductor does normally
to the
does.
secondaries to the load from
And
the
he
If
has
you have
his
enough
transformer
inductance.
in phase.
and the bi-toroid transformer.
When you load it down by
uses reactive power with
by
the
putting
net
a
power
secondary on it,
consumption
then that brings it in
of 0
phase,
watts.
In phase.
and that's when you're drawing real
And that's
power.
when you're in
For now,
unity.
thank you very
That's
much.
unity. When
Right.
they're in phase.
Right.
When
Well,
the
it's
input and the
reactive.
output are in phase?
It's input and output are, but the loading isn't for the primary.
It's not in.
It's the difference between reactive and real power. Where real power is when they're in phase, reactive power is when they're out of phase. So what happens if something is 90 degrees out of phase? In other words, when you have this peak going up for the voltage and then this peak going up for the current, I'll draw it like this. Oh, let's see. Okay, if they're like this, like that, let's say both voltage and current, that's supposed to be two like overlapping there. I know it's kind of hard to see, but if they're doing it like that, they're drawing real power. But if instead, probably help if I had like two different colored markers here, but I don't. If they're like this, where there's the voltage and the current separately, when you multiply those out, it equals 0. So that's strictly reactive power. They don't peak at the same time.
Meaning no load.
Right.
Yeah, they're 90 degrees out of phase.
And when they're in
that's
like
phase, they're a loading.
Yeah, when the two phases synchronize together, that's when you got real power. The second picture that she showed you, when you got the two sine waves and they're 90 degrees offset each other, that's reactive power.
Because of this, you could draw, let's say, a 300 watt inverter to it, and you could power 2,000 watts output.
Oh, supplies.
I put the 2 patents and the simulation in the private chat, so you can see that.
But you got to understand too, this is an AC circuit. You know, most of the stuff I deal with are DC circuit, but you still get a reactive power scenario in my circuit as well. And then to bring it back into phase or bring it back to real power in a DC circuit, when you've got reactive power, you have to dump it into a capacitor bank. They'll bring all that reactive power back into real power again, and then from there you can put it through a full-way bridge or dump it into a load directly. AC, similar principle, it's just using an alternating current.
Well, this thing here is showing the flux, huh?
Yeah. See, normally it would feed right back to the primary, but instead it's going around the outside loop instead.
Yeah, he's created a pathway for it.
Primary. Oh, okay. Oh, he is pulsing. Oh, it's an AC signal, so that's a pulse. So, primary. You making sense of this animation here?
So this is your 60 hertz where it's on and
When
off,
the
on and off.
primary's off, the secondaries are loaded. That'd be the outer box in colors. Outer part of the core.
Well, when the primary is high, the secondary is high at the same time. But what would make it draw the current has been diverted. So the current's out of phase. For the primary, not the secondary. The secondary is drawing real power. Yeah, there, that bottom link there shows more of the test data.
This one?
Right there where it says below next test. It shows a much simpler version of the test to make it easier to understand. At that top is just another core feeding into the bottom core there.
Oh, that's interesting. I never seen
It's a
that.
whole lot easier to make that. So
Yeah,
he
it's
just.
a lot easier. I got
It's
a really
really hard
large.
to see. Yeah, it's really hard to see by that picture, but the bottom core of the transformer is actually cut out. The bottom leg of the transformer on the right side is cut out, so it's feeding into the round core.
Yeah. Okay, I see what he's done. I got a really big core. It's like probably twice that size. Thing weighs like 30 pounds. The thing's just huge.
What is it, from a welder or something?
I haven't got the foggiest idea. I had a guy from Connecticut donate it to me. He goes, "Yeah, you want this toroid I got?" I go, "Okay, how big is it?" It's big. And he didn't tell me exactly how big it was when I received it. He goes, "Yeah, it's probably about 35 pounds."
I've seen some
the same design, but in spherical.
Oh, this thing's huge.
Yeah, this is a different version here, but
it's about 8 inches in diameter. The one that I have.
Oh man, sounds like it might be out some professional audio equipment that's like 5,000 watt output, runs off to 220 volts.
Oh my god! You should. See
I just seen I just seen a guy on YouTube that was restoring the old amps like that. It's the professional audio equipment. They had some enormous transformers in them.
Well, this thing is about 3.5 to 4 inches thick and 8 inches in diameter. It's big.
Damn.
Yeah. It's a monster.
I'd like to get a hold of some transformers like that.
Yeah, she's a beauty, all right.
I was thinking about checking out the salvage yards, see what I could find.
Yeah, you'd be surprised.
So I put this capacitor in there to smooth out. So I was tuning the 436 hertz, the oscillator, to try to reach 432 hertz here on an old battery. Turn it down. A drill battery that I've been pulsing for over a year.
I usually stay with the DC stuff. It's a lot safer.
424. Anyway, this is a square wave generator. I use the super caps to try to get. I'm going to set it to 432 hertz. Steady supply. The voltage. Pulses, you know. You get a nice closest possible. Turning it up now a little bit. Trying to meet on this battery that I've been pulsing for over a year, right? Why 432? I wasn't getting nowhere on the voltage. I mean, I got somewhere, and the voltage stopped at like 3 volts, right? As close as I can to 432. That's it right there, you know. Bounces around there. But anyway, when I got it to sit on 430 hertz or around there for like a day or two, I put this capacitor in there to smooth out. It took me a year just the load side. This is a 3 ohm 10 watt resistor. They kept going. I'm not even using 10 watts, but all right, Mike. Just using the 3 ohms.
All right. Yep.
I'm dropping the plus on the battery, 12 volts. I'm running it through this 3 ohm resistor to limit the current for this square wave generator. And on the output here, on the orange lead going in here is the yeah. If I ever gonna oscillate again, I'm gonna do it with an Arduino that can keep the 432 or whatever frequency I want to use. Keep it steady, you know.
Did we lose him? I think we lost him.
He had to go to sleep, I guess. Sleep. But
yeah, catching up with me too. Oh, what was his name? I missed it. Because it said Faraday Research, but what does he actually go by?
Mike. His name's Mike.
Oh, he's Mike too?
Mike Faraday, yeah.
Oh, okay. Damn, it's like an alien scientist. We got like 3 different Jeremy and Jeremiahs.
Right. There's a lot of Michaels out there too.
Yep.
Tonys. A lot of Tonys, Anthonys.
No kidding.
But if you're trying to get a stable frequency with a tank circuit, yeah, the capacitor will do a pretty good job at it. But if you can trigger a transistor with a stable frequency, I think that's the best way.
Yeah, I'll show you the little thing I made if I can find it here.
I think that's the hardest thing with doing experiments, is getting a stable frequency that's not going to vary, you know? Not even in the slightest.
That's why some of the signal generators are nice. They've got some out there now that are like, they're not continuously variable, but they're like $3 or $4, and they just have standard frequencies they can use. So those might come in handy for what you're doing. Oh, damn, I was going to show you. Yeah, I've got where I took a GPS module and shit.
Yeah, but
my health is a disaster. But basically, one of the GPS modules, and when it locks onto the satellite, and so it's like an extremely precise frequency. So,
and how do you
when you type in whatever frequency, it's like exact, and you can tell at any frequency you want. Well, anything up to like 8 megahertz, 10 megahertz.
They're using function generators for that.
No, this is direct digital synthesis. In other words, it divides it down.
And what do you suppose the circuitry in those generators are? A bunch of capacitor arrays?
No, it's completely digital.
Well, what's triggering the digital?
It's literally it has its own crystal oscillator built in, which is temperature controlled, so it's more stable than usual already. And then it takes the satellite GPS signal and it locks with it. And the satellite signal is using cesium. I think pretty sure it's cesium clocks. So that's our most stable clocks that we have now. So it's locked into that, like within a few parts per billion. So it's not going anywhere. And even without the satellite lock, it's still like I think it's something like
crystal oscillator is not tunable. Is it?
Well, it's tunable, but it's not continuously tunable like analog. When it's tunable,
you have to have multiple crystals just to get your different tunings. You can't tune one crystal.
No. It's look up DDS, direct digital synthesis. In other words, what you do is it takes. Let's just use 1,000 for example. Let's say it's at 1,000 hertz. Okay, 1,000 times a second, and you want 10 times a second. So you divide it by 100, and then you get your output. If you want 500 times a second, you divide it by 2.
Oh, so
if you want some odd number,
let's say logic to do that.
Right. If you want some odd number, like let's say 700 times, and the reference frequency is 1,000, then you have to divide it by something like 2.3, and it'll actually sync, and sometimes it'll.
So they're using crystal oscillators, and from there to convert their frequencies, they're using transistors.
Yeah, there's digital logic gates.
Right, or transistors, basically. Which is
it's very precise. Yeah, if you look up like a HP.
Right, that would be a better way. That's a much better way of doing it than a tank circuit or capacitor discharges.
Right. Well, that's what you're going to find that's what you're going to find in any TV right now or any cell phone. Pretty much everywhere now, it's all direct digital synthesis, all divided down, or sometimes it's multiplied. Let's say you start with a frequency of 1 megahertz, you can turn that into 20 megahertz if you want.
Because
because it'll instead of divide it, it'll multiply it. I'll say it again.
So a PWM, a pulse width modulator, that's not using a crystal oscillator in there. It's using a tank circuit.
Well, no, you can do PWM digitally too, like the Arduino. The only difference is
that's what
instead of an analog circuit of something charging up and having a comparator, you're just counting digitally. So let's say it's 100 seconds. You're turning it on and then waiting. Let's say 5 seconds to make 5%, or 10 seconds to make 10%, or 50 seconds to make 50%, or it might be 50 milliseconds if you're working off like 100 hertz. So the Arduinos,
the 50 millisecond duty cycle.
Right. Well, the PWM and duty cycle is the same thing. It's not the same thing, but it's.
But they're not using crystal
PWM sets the duty cycle.
They're using the tank circuit in the PWM. That's what I'm saying.
No. Well, they're starting with the tank circuit that drives the digital oscillator. But it's a crystal oscillator tank circuit. Well, it's a crystal oscillator tank circuit, so it's really accurate to start with. The Arduinos, if you've ever used the Arduinos, that's what they use.
How do you combine the tank circuit to work with the crystal? I had seen this once.
Oh well.
But somehow the crystal can control the charge rate of the capacitor.
You've just seen it in your last circuit. Remember that piezo?
Right.
That was the same as a crystal.
Right.
And I don't mean similar. I mean identical. The piezo is a crystal.
So the piezo creates the charge frequency.
Barium titanate or quartz. It's the same principle. It's a capacitor and inductor and a resistor combined. Well, capacitor and inductor and and everything has resistance. But the Q factor of it for a crystal, can be 100,000 or more, which is basically, in other words, like if you just have like a regular tank circuit, let's say it might be a Q factor of, let's say 10, which means it'll like go up like this, gradually like this, and then gradually back down. Okay, let's say if it has a 10, but if it's 100,000, you can have your motor running in that frequency range, and you'll get higher or lower output there. But if it's a crystal, it'll be like barely zero, and then all of a sudden go way up to a factor of 1,000, and then 1% later it drops down to zero. So it holds it in that very narrow band of frequencies. But that's why they like crystal oscillators so much. It's pretty much an all or nothing thing, and then you can like fine tune it a little bit with a small capacitor in parallel with it. But it's like a you're tuning it like a few tenths of a percent, or a few hundredths or a thousandths of a percent. You're not you're not like you're not going to get any real range from it. You're just making it more accurate, if you know what I mean. Right. But that's what they call a trimble. If you ever look at frequency cap or a frequency counter, it'll say trimmer on the back of it. It means a trimmer cap, or frequency adjust, sometimes they're called. But it's the same principle. And the thing about it is let's see.
Well, that's good to know that there's actually a crystal in a PWM, because I didn't think those things were that
there
accurate.
Can be a PWM can be or not. I'll see. I just ordered a
$20 PWM probably doesn't have a quartz crystal in there, little crystal oscillator chip. It's just a little. It's not a very expensive part. Nonetheless, they don't put them in there in the cheap ones, probably.
Right. I just ordered this, if you can see it, off of eBay for like $8. That's a function generator. That's actually an analog source, but then it's divided down digitally to make the square sine waves. And then there's another one I can show you here that I just got, which is a digital one. See if I can find it. I got it like 6 months ago, so I hate that when they remove the pictures of stuff. Yeah, because it's its own. Oh, found it. There we go. And this is only $5. Well, $4 or $5. Can you see that?
Yeah, that's it. $4 or $5.
Yeah, and it's a signal generator, PWM, frequency adjustable. So
yeah, they got a lot cheaper
it's like $3 shipping. So it's $7, but if you get like 2 or 3, they're only like $5 a piece. So and that little thing there is only it's only like 3 inches by like 2 inches too.
That's probably better to trigger your switches with that.
Yeah,
isolated.
It's a whole lot more accurate, but you're not going to be able to like fine tune it for a range, because it's only going to be like certain frequencies that it runs. You can go up and down, but it's going to be like 100 hertz, 200 hertz, 300 hertz is not going to be a big area.
Oh, 300 hertz is more
Oh
than
wait.
enough.
Oh, okay. Oh no, that was the old version. This one actually says you can change it by. Let's see.
Most of them go up to like 40 kilohertz or 30 kilohertz.
This one says 1 hertz to 999 hertz for the top, and then the very top range is.
So you can change the
Let's
dip
see.
switch on there and you go up to a higher frequency.
Let's see. I was going to see if I could share my screen with you so you can see what I'm seeing. There, I'll just say entire screen. Hopefully that'll work. Hopefully. Okay, where'd my thing go? Okay, can you see that? Can you see me my screen now? Or is it still not working? For some reason, this never wants to work for me. That's why I just picked up the camera. But yeah, it says in the specs there you can go up and down by a few hertz. Okay, no, it didn't show it, huh? No way it does that. It even says I'm sharing it. That's weird. Wonder if it'll let me just share one tab and then select that tab. Present. Share screen. Sharing videos works best on a good computer. Oh, no shit. Okay, let's see if this works. Did it change at all? Oh, there's two at the bottom. Maybe I got to select that. Oh, okay. Stop screen. Either that or maybe you have to select it. I don't know. Do you see where it looks like an extra person in there now? It says you're in the show. Present. Well, beats me. But either way, it shows it. I'll pass that. I'll pass that link on you for the exact thing I was looking at. That way you can look at it yourself. But yeah, that one there is like $5 a piece. So unfortunately, they did something with the what do you call it, the tariffs and stuff like that, where they didn't have before. So all that cheap stuff from China is now that had free shipping now is like $3-4. You're muted. It's not showing me as muted. It's showing you as muted. You there? Raise your hand if you can hear me. Yours says mute. You're muted. Let's see if I could hear this. Let's see if we can get it to this one right here. Right here. Huh. I wish I could help you, but this spot right here, this one. Try that. Oh, didn't know that would do that.
Testing.
Oh, there you go. You had your mute on. I can hear you now. Can you hear me okay?
Testing. Can you hear me?
Yep. Can you hear me now? I can hear you fine.
Technical difficulties. Testing.
Yeah, I hear you.
I don't hear you.
Seriously. Oh, maybe I bumped something when I did this. It's.
Can you hear me?
I hear you good.
Can you hear me? Testing.
Let's see.
Let's see here.
Hey.
I don't know what happened there.
That's weird.
Testing.
Can you hear me now?
Yes, sir.
Okay. Yeah, my mic and everything showed it was working. That's weird.
I had to reload it, I guess. Froze up on
Must
me.
be a driver thing. Yeah, you were muted there for a while on the bottom left. And Jeremy
yeah.
does that all the time. I don't know which button does that, but he does it by accident all the time. But at least it got things working. Yeah. Unless you've got a button on your headphones, I don't think it could be that, but I know some of them do. But I just use the regular one that's built into the camera, so it makes it easier.
My Bluetooth is wireless, so maybe you got the Bluetooth speakers also, and sometimes they bounce each other off.
That might be. Yeah.
But
I forgot I could type something. I completely forgot I could type something. Here, write it on a piece of paper.
yeah, right.
It's like, I've got a damn keyboard. And here I'm writing it on a piece of paper. I wasn't sure if you could see the private jet part either.
Old habits die hard.
Yeah, no kidding. That's why my passwords, they've got all these things where they store it on the computer. It's like, nope. I keep mine on a piece of paper that I keep hidden. I have yet to see anybody that can hack into a piece of paper.
Right.
You might break into my house, but
when you got two-factor authentication, you know, it's better
well,
than
even
a
there,
password.
it's like it can intercept the keyboard input, so it doesn't matter how much encryption you have if it intercepts that.
Yeah, but you know what
And now they've got
two-factor
these
authentication
new.
is?
Well, that authentication is good, but if it's listening to what your keyboard's putting out, it can still intercept it. You know, because back and forth across the internet, it can't intercept that.
You're right.
But it can intercept this talking to over the USB to the computer.
Yeah, but those websites are encrypted.
Although this is encrypted a little bit too, so. But there's a way to
StreamYard
beat
is
that.
encrypted?
No, the keyboard, the Logitech keyboard, between there and the
Well, it looks
USB
like
connector,
StreamYard is
they encrypt that so you can't intercept it wirelessly.
StreamYard is encrypted.
I'm not sure if it is or not.
You know how to tell?
Yeah.
You go up to the link at the top where it says StreamYard.com. To the left, there's a little lock, like a master lock image.
Huh?
You click on that, and it says connection is secure. If the lock is unlocked, the connection is not encrypted. So when you go to your bank website, you're going to see that same lock there.
Oh, you mean on the right on the next to the website?
Yeah, that means that the connection between your computer and the bank's website is encrypted.
It doesn't show it on this one. On mine, it just says StreamYard.com and then the letters.
Well, to the left of the S is an image of a lock, a master lock, like a lock padlock.
Look at
Oh, what is it? You don't have it. Oh.
I don't know. It's like 2 lines.
Click it. Click the 2 lines. Connection is secure.
Oh, okay. I didn't know that was there.
See?
Huh. How about that? I was looking for like the other places that get like
that's how you know
HTTPS and stuff. I was expecting that.
That too, but if you see the lock there and it says it's secure,
right? Okay.
It's encrypted. So without the StreamYard link, you don't know the encryption.
Yeah, I like the background. Haven't seen that in a while.
Yeah, right? Wait, check it out. You didn't recognize that?
No. Oh, like the hailing thing.
Yeah, Star Trek.
Yeah, that's been a while. Yeah, they had way better stories back then.
Gene Roddenberry.
Yep. Yeah, I seen the whole thing about them where they were making fun and saying he's a misogynist and everything. It's like, oh, hell, he has great stories. Stop complaining.
What's that?
About Gene Roddenberry and his life. And they were like, yeah, he'd been with a lot of women. Yep, sure. I would too.
That's that means? Misogynist is when you beat up when you're
no, well, misogynist just basically any excuse for something that women don't like now, but no, that's well, just like abuse now. Abuse can be pretty much anything. You're raising your voice to somebody is. Are we still in line? Probably shouldn't say this on YouTube, but even that counts now.
How do I end the stream and go? What do you call it after? What do they call it?
Because the AI actually listens to us.
In StreamYard, how do you do the after party thing? The end the stream and. How do I end the stream and you stay connected? How do you do that? Click end stream.
I'm not sure. I know you can do it, but I'm not sure. Stream to your audience. You still got a page that says like for YouTube. I would think it would be there, but
And
site settings maybe.
you want to get off the live here, right? So end stream.
Yeah.